At its core, Docker provides a way to package and run applications in isolated environments called containers. A container can be understood as a lightweight, standalone executable package that includes everything that's needed to run a piece of software. That's the code itself, of course, but also an operating system, the code's dependency libraries, environment variables, and configuration files. This encapsulation is both powerful and efficient. Docker runs on Linux, Windows, and Mac OS. Deployment via Docker is simpler, it's faster, and more platform independent. But it's also a great tool for packaging your own applications, and that's exactly what we're going to do right now. To demonstrate how to use Docker, I'm going to show you a simple Python teaching tool that I use for a course that I teach at University of British Columbia. This is a Hello World command line application written in Python that integrates the OpenAI API in order to translate the text, Hello World, into a language of your choice. It's a fun little app, but the important thing is that it's already configured to work with Docker. So let's build a Docker container for this application right now and then run that container locally from our dev machine. Complete setup instructions are in the README. To run this, you'll need Docker and Docker Compose on your local dev machine, but I've added detailed instructions to the README on how to install both of these. I'm going to be using Docker Desktop for this tutorial. You'll also need an OpenAI API key, and I've added instructions for this as well, in case you'll be creating an API key for the first time. You will not need Python nor a Python virtual environment because Docker Compose is going to take care of both of those for you. Okay, here we go. These commands are all copy and paste to the command line of a terminal window in Mac OS or PowerShell in Windows. First, you're going to clone this repo in order to download the source code to your dev machine. CD into the newly created OpenAI Hello World folder. I'm going to use VS Code to show you this project, but you can use whatever code editor you prefer. The Python Hello World application is here in the app folder, but in this video we're focused on how to package and run it with Docker. If you want to know how the code actually works, then look for a link to that video in the video description down below. Docker containers are defined by a Dockerfile, which is simply a text document containing all the commands needed to build the Docker image. Let's break down the key elements of this Dockerfile. This container begins with a base image that already has Python 3.11 pre-installed, and it's based on the official Debian Linux runtime. The image itself is maintained by the Python organization, so it's a good foundation to build on. We're going to add our Hello World Python application to this base in order to create a new image that's much more exciting. We're going to physically copy the source files for our application into the container. Note that app refers to the app folder in this project and that /dist/app is the destination inside of the container's file system. We'll also copy the Python requirements file as well. Think of both of these lines as virtualized import or upload functions where we're going to copy the files from your local file system to the container's file system. I've added some environment variables. The main one of interest is OpenAI API key, which we're going to pass in at runtime. Docker's environment variables are identical to environment variables in a bash shell, by the way. Next, we're going to pip install the packages listed in the requirements.txt file, which in practice is effectively just the OpenAI PyPI package. This will also be executed inside of the container, so you'll only see these packages while they're being echoed to the screen during the build process, but otherwise they'll be invisible to you. And lastly, we need to tell Docker what it's supposed to run when the container's launched. This command is equivalent to us typing python-m app.helloworld on the command line of our dev machine, except that in this case, everything will be executed from inside of this container instead of from our local file system. Okay, let's build this thing. Run make on the command line. This is a convenience function that will generate online help that describes all the make commands in the make file of this project, but running it has the convenient side effect of initializing a .env file for you in the root of the repo. Afterwards, you should add your OpenAI API key and your Docker Hub access token if you have a Docker Hub account and you want to push your container, which you could do later if you wanted, or not at all. Your credentials should have formats that are similar to these example values that I'm pasting. Run make docker build to create a new container on your local dev machine. Docker needs to be running, otherwise you're going to see an error in your console window that's similar to this one. Everything that Docker Compose does will be echoed to the console. This entire process should take you around 90 seconds. When it finishes, you should find a new image and a new container inside a Docker desktop. To execute the Hello World application from your new Docker container, run make docker run. This will deploy the container inside your local Docker runtime. Your response should be similar to this one. If you have a Docker Hub account, then you can configure and run make docker push to upload and publicly share your application as a binary runtime. This makes collaboration and distribution incredibly efficient, enabling teams to build, manage, and secure their applications across the entire development lifecycle. It's pretty cool. Lastly, if you want, you can tear everything down with the command make prune, but be aware that it will destroy everything inside of your local Docker runtime, including unrelated images and containers in the event that you're already using Docker for other projects. So use this command with great care. The actual command line instructions that you just ran are saved in a file named makefile located in the root of the repo in case you'd like to see more about how these commands actually work. And there you go. You just built, ran, and hopefully pushed a custom container to Docker Hub. This code follows a lot of important best practices that I cover in other videos in this channel. So like and subscribe if you found this helpful and you want to learn more about doing full stack development the right way. Thanks for watching.